Hey friends, welcome to our weekly Data Talk, a show where we talk with data science leaders from around the world. Today, we're talking with Chakri Cherukuri. He's a senior quantitative researcher at Bloomberg. Today, we'll be chatting with him about machine learning and how it relates to the work he's doing with financial data there at Bloomberg. Chakri, thank you so much for being part of the show today.
Thanks a lot, Mike.
Chakri, can you share a little bit about your academic journey?
Yep, absolutely. So I did my undergraduate degree in mechanical engineering from Indian Institute of Technology. And then I came to US and I did a master's in computer science from Arizona State. And after that, I really wanted to ride the dot-com bubble. So I was working in Silicon Valley for startups doing enterprise software. So that's where I learned a lot about software development, and I was a really good software engineer. So after that, I wanted to, because of family reasons, we had to move to East Coast. So I thought I'll join the financial industry. And I worked at investment banks like Lehman Brothers, Goldman Sachs, where I got to understand how financial services companies and investment banks work. And after that, I was really interested in quantitative finance. So I did a master's degree in computational finance from Carnegie Mellon. I did that part-time while working at Goldman Sachs. So it was a very intense 3 years.
Wow.
And then I joined Bloomberg in their quantitative research group. The group is headed by a very famous quant. His name is Bruno Dupier. He invented the local volatility model. So I really liked what the group was doing, and we had a lot of freedom to pursue a lot of research projects. So that's what attracted me to Bloomberg. And I've been there for last 7 years now.
Wow.
So yeah, that's about it.
That is amazing. What an amazing journey. It's really interesting as you're sharing that your background was originally mechanical engineering, and then you started to move more into the computer sciences, and then your transition over to the East Coast. You're already like super busy doing work at Goldman Sachs, and then you're also in graduate school in a very accelerated top global program at Carnegie Mellon. Tell us about that period, because you're already very successful. You're already working in an industry, and then you decide, you know what, I want to go back to grad school.
Yeah. What really when I was working at investment banks, I really liked the field of quantitative finance, where you apply a lot of mathematical techniques for pricing securities, or for risk management, or for asset allocation. So there's a lot of math which is used in finance. And that's what I said, okay, let me get a formal education in this field. And it was really intense because I was doing the degree part-time, and I was working full-time at Goldman Sachs. And we also had, both of my boys were born during that time.
Oh, wow.
So it was really brutal, managing so many things. But it was a fun experience. I really enjoyed studying, and I really enjoyed the program. And I'm very lucky to get into a nice group like the Quant Research Group at Bloomberg, where I get to use some of the things which I learned in grad school.
That's so cool. Were there any classes you took during that period that really stand out to you, that you found super helpful, especially in the work you do today?
At that time, machine learning was still not that popular. So I took courses mainly in the classical quant finance, like stochastic processes, or asset allocation, and some statistics. And there is some computing, but I had some advantage there because I already have some programming background. Taking courses in the quantitative finance, the classical courses, and I really enjoyed those courses, and we had very good instructors at Carnegie Mellon.
How was what was it like as you were, because you're obviously super busy at work, and especially working in the investment space, very long hours, and working for a top firm like Goldman Sachs. So tell us about kind of the juggling of life, college, in a really very difficult program, and then very stressful career.
Goldman is a very challenging place to work, and you have to work long hours. But it's just a matter of managing your time, right? And also, luckily, I was doing the course from the New York campus, where the videos were live streamed from Pittsburgh campus. So one thing about the program was I could watch the lectures on the weekends. Like, I don't have to go to the classes because the classes typically had I had to go take some time off from the work to go to the classes. That was not going to happen. So luckily I could go home, or on the weekends I could look at the lectures again and listen to the courses. It's just a matter of managing your time. I think everyone goes through these kind of phases in life, and if you really want something, you have to work hard for it, unfortunately.
That's right. That's right. You mentioned that you already had at this point some background with computer programming languages. What were some of those languages you learned early on that was super helpful for you?
Yeah, so my main background was in building enterprise software applications in Java and database technologies and the classical, the server-based technologies. I also had good experience with scripting and automation, like using Python and Perl. But the program, you had to learn some scientific computing from software development. Like we had to, it's mostly scientific computing in the courses, like matrix manipulations or doing some statistical computing. And those are the things which really helped me in transition to quant finance.
Oh, really?
Yeah, like numerical methods.
Okay. So one of the questions we get in our data science community a lot is from people who are just starting out and they're curious about, there's all these different programming languages. What advice do you have for kind of the first languages to learn? And I'm just kind of curious from your perspective, what languages would you advise for young data scientists who are just starting out that they should really get a good handle on?
I would say Python, because personally, when I started at my group at Bloomberg, it was a MATLAB shop. MATLAB is a numerical computing package. But what I like about Python is it's a full-fledged programming language, and it has a very good support for scientific computing with packages like NumPy, Pandas, and SciPy. And recently, there is a huge, all the deep learning revolution which is happening around us is all being done in Python, like TensorFlow and Keras and PyTorch. So Python has an excellent support for both machine learning and statistical computing, numerical computing, and also it's a full-fledged programming language. Like, for example, you can build web apps or you can access databases. All those things are possible with Python. But of course, put these models in production, I think it's typically Java or C++, which are still predominantly used. So you have to be at least comfortable. But as a data scientist, if your responsibilities are mainly building some prototypes or doing some research, and there is a separate team which is deploying these models into production, then you don't have to learn these heavyweight languages, I would say, like C++ or Java.
Working in the financial space and working with so much financial data, can you talk about some of the challenges that data scientists face in your field?
Yeah. So finance contains a lot of time series data, like you have time series of stock prices or the fundamentals of all the stocks. And unfortunately, the data is way too noisy compared to the classical data sets you see in technology, like speech or language translation, where deep learning techniques are being really being applied, or images. Unfortunately, in finance, the data is way too noisy, and trying to apply these machine learning techniques on financial data sets, especially financial time series, I would say will not be. You have to be careful. Like for example, if you want to put a lot of money or you want to make some trading decisions based on these machine learning models, you have to be very careful, because they may not. The models which are trained using historical data sets may not generalize well for the future data sets. So you have to remember that. And there is this huge demand for alternative data among investors, right? They're trying to text-based data sets like news stories or tweets, and trying to look at social media data sets to gain some edge in the financial markets. So a lot of techniques are being applied, especially in the alternative data space, and text and even satellite images, like some hedge funds are using. This was all done in the past, and there are some data vendors who are providing these kind of analytics which are based on alternative data sets.
Can you talk a little bit about why the data in the financial space that you're working with is so noisy? Why is it so dirty?
I won't say it's dirty. It's just that in finance, the financial time series are what we call non-stationary. That means they keep changing a lot. The distributions of data, which we have seen historically, may not repeat in the future, or we might encounter some regimes which we haven't encountered at all in the past. So in the classic machine learning, we need some training data. And the big assumption in the machine learning is at Bloomberg, what we do is we are a data vendor. We provide analytics and sentiment scores, which are based on these news stories and tweets. And I've worked machine learning models where we try to classify the news stories or tweets based on the sentiment, which is expressed in the tweet, like as a negative, neutral, or positive. And then what Bloomberg does is we build these machine learning models, and then we compute the aggregated sentiment score of stocks, and then we sell them as enterprise data feeds to our customers. And customers, in turn, can use these sentiment scores for building profitable trading strategies. Yeah.
That's fascinating. So incorporating in social sentiment data, like the feeling on that brand, on that stock, can help inform the other business data that you have around that stock.
Yep. For example, like someone can tweet that, I'm very bullish on Apple. Apple is going to have very good earnings in the next quarter or something like that, right?
Yeah.
So that's a positive sentiment, right? And so those can become additional features, machine learning model. The fact that there is an emoji in the tweet, or the fact that there is some video or some image in the tweet, they can become additional features. But again, I'm not an expert in doing all this additional, but yeah, they can definitely become like additional features into when you train the machine learning model.
That's great. No, I think it's super, super smart. And I love that, how creative your team is with handling, all these different data points to help make better decisions. And I think social media data is very, very fascinating and a great way to kind of learn more about how people are thinking about certain stocks or certain companies. Any other favorite use cases? I love the social media example.
Yeah, and I mean, just to be clear, Bloomberg has a lot of machine learning teams who, it's not just our group who's doing all this. I mean, there are machine learning teams in the engineering group where they process all these news stories and train machine learning models. And in our group, we also look at mainly like financial time series based data sources, and we're also looking at trying to train or use machine learning when it comes to option pricing. For example, price options. It's a very big topic in the field of quantitative finance, where numerical methods like Monte Carlo simulations or partial differential equations are used for pricing these options. And we are trying to see if machine learning can help us build faster pricers, right? Because we can train offline a very large machine learning model on where these training data sets are manually generated using these slower methods, numerical methods, and then we train a machine learning, a deep learning model to predict the prices. And once the model is trained, making predictions or pricing becomes super fast, because in deep learning, pricing is making predictions is just a bunch of matrix multiplication. So predictions have become like super fast. So that's something we are looking at. But these are all still in like an experimental phase, and but these are all some interesting topics. We'll see how machine learning is being used on the sell side, and also on the buy side. We look at trying to do some kind of investment strategies or trading strategies using machine learning. These are some of the things which our group is doing right now.
For people that are just starting out analyzing this sort of data and working with these sorts of machine learning projects, are there any, like you notice, like very common or easy mistakes to make when working with this data or working on these machine learning projects?
I think it's important to first understand the data, and it's very easy to train a machine learning model because all the packages and the software make it just to train like 100 different models, and we can even automate the whole thing using this AutoML and other techniques and run the whole thing on the cloud. So it's important to make sure that how the model is doing out of sample. And even if you have some good performance, in finance, unfortunately, the stakes are very high. Because if you give these models to, let's say, investment firms and say, hey, you know what, guys, I have a cool machine learning model. Why don't you start trading using this model? They're not going to believe you, because there's a lot of money being put into this trade, into these investments, and they want to understand how the model is doing. We can't just tell them, hey, you know what, this is a fancy black box model using some of the latest deep learning techniques. They're not going to buy it. Model explainability is very important. You should be able to explain how the model is making its decisions or making its predictions. That's crucial, especially in fields like finance and healthcare, where the stakes are very high.
No doubt.
Model explainability, all these things, you should be able to explain how the model is making its predictions to a layman, or just people are not used to these kind of things. We can't have a very black box algorithm where it's very accurate. They're not going to believe it.
Yeah, I think that's got to be like a super important skill for a data scientist, to be able to take all their knowledge about that particular algorithm and be able to explain it in a simple way to somebody who's outside the field. Because that's super important. Like you said, it can't just be like, oh, we take in this data and here's what you should buy. This is like financial data. This is like making recommendations on possibly buying a stock that can, if you're all in on a certain stock, you can lose a lot of money. So I got to imagine, is this very stressful to work on this type of these types of projects?
So Bloomberg does not trade. So we just do some research and prototyping, and we build some white papers, and we make recommendations, but we don't trade. So it's fun to be in this environment where, of course, if you work at a hedge fund or where you have to put these models in production, so I'd imagine it would be very stressful, and you have to monitor these models every day to make sure they're not making some very crazy predictions or anything. But yeah, here at Bloomberg, in our group, the goal is to terminal. We build some, we show that there is some value in these data sets. We write some white papers, and we do some research and case studies. And then it's up to the investors who want to take this research. What this sounds like a promising idea. Let's put it in production. Let's start trading using these ideas. Then you'll see whether these models work in totally out of sample or not.
When you're working on a project like this, what does your team look like when you're discussing like a challenge or product, and you're developing a machine learning algorithm? What type of feedback are you looking for? What type of people need to be in the room when you're discussing these things?
Yeah, it's very important to have some collaboration, especially when you're working on these machine learning projects, because you need to also have some domain knowledge. And our manager, like Bruno, has a very good intuition about the quantitative methods and in the financial industry. So obviously we'll run our ideas with him. And we also have some who come from hedge funds in our group who are very knowledgeable about the investment industry, and we take inputs from them before we apply this thing. So it's a very collaborative and teamwork effort, and it's important to get different perspectives when you build this kind of models, especially in domains like finance, where you need to have some domain knowledge blended with the knowledge of machine learning and data science.
What are some important skills or traits that a person needs to have to be very successful if they're joining your team?
You need to have a good background in like quant finance. That's what our group does. It's called Quantitative Financial Research Group. That's our number one skill. So you need to have some solid background in different techniques which are used in the finance, like stochastic calculus or numerical methods, good background in math, linear algebra, and also some good knowledge of scientific packages like scientific computing, like using Python or MATLAB or R. Those are the skills we look at. And for someone senior, we also expect them to have some kind of intuition of various financial instruments and understanding of different like what are some of the skills you need on the sell side versus buy side, and have some knowledge of financial math.
What I love the fact that you've been at Bloomberg for a long time. What do you think has helped keep you there? Because I got to imagine that the team structure that you're with is enjoyable to work with. I'm kind of curious if you can kind of talk about, like, for someone who's just starting out or looking for a good data science job. I mean, to me, like, the team environment is really, really important. That culture, you have to be able to enjoy that side of it if you're going to be there long term. So I'm kind of curious. Can you talk a little bit about, like, what has kept you at Bloomberg so long?
Yeah. So first of all, I really like the group where I'm in. We have a lot of freedom to pursue the research projects, and there is also lot of support from our manager to, like, pursue different research projects. And that's what I like about it, the freedom. I also have the opportunity to learn the latest developments in be it machine learning or quant finance, and I get to attend a lot of conferences. I have freedom to speak at a lot of conferences. So all these things to me, like, let's say, there's no, if you work at any other, like I worked at like other places where the work is really interesting, but it tends to get streamlined, where you focus on only one thing, but of course you become an expert in that field. But here, what I like is there is a broad set of projects which I can work on. And more importantly, I have the freedom to choose what projects I want to work on. And we are encouraged to pursue some new projects, or let's say I want to learn about latest developments in deep learning or NLP research, I can do that. So
that's cool. That's great. I think, yeah, freedom is super important, and being able to satisfy that intellectual curiosity that you have is awesome. How do you, like, with all the changes that are happening in the machine learning space and in data science, how do you keep up with all the changes?
Yeah, I know. Deep learning especially is like really, really bleeding edge. Like every day almost there is a new paper coming out claiming that their approach is better than the approaches. Obviously, I can't keep abreast of all the developments which are happening. So once in a while, I read the latest developments, and depending on the problem, let's say I was working on some machine learning model, and I read about this newer technique of tuning hyperparameters using Bayesian optimization. I said, hey, this sounds interesting. Let me read about that. Then I read the latest papers, and I found out that 2 years back, there was some latest research which was released on using this Bayesian optimization based hyperparameter tuning, for example. Again, all these research, it's good, and you need to be able to quickly read these archive papers and put this model. And the nice thing about this is someone or other is always putting their code on GitHub. It's a true democratization of all the latest deep learning research, and that's what I really like about it. So, but again, whether these models and the approaches will work on your specific problem, the only way to know it is test it and try to use them. It may or may not work because it depends totally on the data set you're using and on the specific problem you're trying to solve. But it's important to keep abreast of all these latest developments, and I know it's a challenge, but I generally follow the medium towards data science blog posts, or keep up with the latest developments which are happening. But I can't like read each and every paper. So yeah.
Yeah, I was gonna ask you some of your favorite sources. So you like going to Medium and kind of following the data science conversations there. Any other tech publications or?
I read papers on Archive, and whenever I get some alerts about some latest developments going on. But again, as I was mentioning, when I'm solving a problem, I try to see what are the latest approaches or latest research which is going on, which will help me to solve that specific problem. Then, if I'm interested, I'll go deep into the that specific research area and try to understand. It's very need to know basis as opposed to trying to just read up on everything. Or for example, if I'm doing some NLP data set, I see that, oh, okay, there is some latest research which came out where their approach seems to be superior to others. Let me try it out. And the nice thing is all this research are come up with code which is available on GitHub, which you can easily download and try out things and tweak them to according to your use case.
Before we got on the podcast, we were talking a little bit about the work you're doing, and also how you are also giving back to the community. And I think it's so cool that you are mentoring others, and also speaking at conferences to help this next generation of data sciences come up. And I was wondering if you can talk a little bit about the importance of giving back to the data science community.
Yeah, I get to go to a lot of conferences, and I also I'm invited to conferences where I'm asked to give some mentoring talks. Recently, I did similar talk at ODSE, which is I think Open Data Science Conference in the New York City. And I also, like O'Reilly, for example, invited me to speak at a lot of their conferences like Strata and AI Conference and JupyterCon. We do a lot of work in Jupyter Notebooks. And I share some of that knowledge by doing some online training on their platform, O'Reilly platform. And I also participate in the workshops where I help attendees try to understand how to build some of the stuff which are showing the conferences. Like data visualization we did a lot of work there. We actually open sourced a plotting library called BQplot. And I talk about that and try to show some of the stuff in the conferences.
You mentioned some really good conferences. How do you know, like, because if you go to Google and you type in like data science conference, you'll find just like tons, right? So, and some of them are going to be really, really good. Some of the conferences might be more salesy, right? Like, oh, this is not really going to be worth my time. How do you kind of navigate that and decide on, okay, that's a good conference I need to be at?
Yeah, I prefer to go to conferences. So I have, as I was mentioning before, I do a lot of work in the Jupyter Notebooks. So I generally go to some tech conferences where I talk about the data visualizations, but all these are use case driven. So I show some use cases in finance, machine learning, and some technology. And those are like, for example, conferences like JupyterCon, which did not happen this year, but it happened last 2 years. And Bloomberg actually funds some of these projects.
Oh.
So I talk about, and I also spoke at a conference called QCon, which is a tech conference, and it's not like a business conference. It's pure tech conference. So I get to go there and talk about some of these technologies. And I also go to some finance conferences, which are geared more towards finance professionals. Like I speak at Princeton Trading Conference, where I talk about machine learning, applied machine learning in finance, and AI conference, which is by O'Reilly. They have some business sponsors, and it's more, I talk about like financial use cases, for example.
That's very cool. How do you, you were talking about your kids. How do you talk about when your kids ask you or family members ask you, like, Chakri, what do you do? Dad, what do you do?
Yeah, my sons, like, they always keep hearing me talk about Jupyter Notebooks. They say, oh, Dad talks only about Jupyter Notebooks, Python, and machine learning. I don't know what it means, but it's fine. I mean, I don't want to push anything on them. But I think it's important for kids to understand all these developments which are happening, and even in schools, all these programming languages and all these STEM courses. They are teaching a lot of Python and some statistics
in the classroom.
Yeah, in the high school students. So I see a lot of interest. I think all this AI revolution which is happening.
That's so funny. So are you kind of guiding your kids to like get like a good understanding of a little bit of data science while they're in school right now?
No, they're still very young.
Oh, they're still very young. Oh, okay. Yeah, they're like 3 years old, and you're like teaching Python. That's so funny. Before we go, do you have any advice for data scientists just getting out of college, getting their first job? Advice on kind of sometimes choosing your first job makes a big impact on where you end up going. And it's very hard to find sometimes that first job because you're just coming out of school, and a lot of jobs want experience. You might not have like any sort of work experience. And so I was wondering if you can give any advice for these young data scientists.
Yeah, I mean, there is an intense competition in this field, and every company seems to have some data science roles in different groups. And there is a lot of hype about this whole AI and data science field these days. And I think, and also the fact that there's a lot of demand and there's a lot of competition. So the only way to differentiate and stand out is to either to contribute something, or like, write a blog post, or participate in Kaggle competitions, or build your own models and publicize them on LinkedIn or Twitter or whatever medium. And I see a lot of young students and also young people doing all these things, and it's important to stand out. And there is intense competition in this field. There are only so many jobs, and there's a huge amount of people claiming to be data scientists. I think my advice is, develop a passion. If you really are passionate about data science, put something on GitHub, do a project, as opposed to just trying to send your resume. It's not going to work because there's a lot of competition. So you need to differentiate yourself. So do a project, participate in Kaggle, and do some work on real data sets. We can't just run some machine learning models to say, hey, I just know how to train logistic regression, now I'm a data scientist. It's not going to work. And you need to also understand to some level some mathematical aspects of these models, as opposed to just blindly using different packages and trying to train models, and try to understand the data, have some good background in statistics. All these skills are very important, and some background in math, or trying to understand how the model works, or the mathematical aspects of some of these models is also crucial, so that you can explain. You'll be able to understand the models better, and you'll be able to decide which for which situation you need to use which model, and what are some of the pros and cons of a specific machine learning model. Those are all the things which are important, I feel.
That excellent. Great advice. Thank you so much, Chakri. For those who want to follow you, connect with you, or they have a conference coming up, would love for you to speak, what's the best way for them to connect with you?
I think I'd say LinkedIn. I'm active on LinkedIn, so I see a lot of young students and professionals inviting me, or sending me invites, and I'm happy to collaborate with them. And if I have time, I'm happy to chat with them. I work in New York City, so I keep meeting students and who come to me for advice, and I'm happy to, depending on my time, and I'm happy to help them out in any way I can.
Wonderful. For those listening to the podcast, I created a short URL that goes to a blog post that features a video with Chakri, and also links to his various social media profiles. He's on Twitter, he's on LinkedIn. So if you want to connect with him, follow him, please go to the short URL is just ex.pn/Chakri, which is spelled Chakri. So again, ex.pn/Chakri, and that will bring you over to the Experian blog post, where we have Chakri's bio and links to his social media profiles. And like you said, a great place to connect with him is directly right on LinkedIn. So again, you can get the link to LinkedIn from the Experian blog post, or you can go straight to LinkedIn and just type in Chakri's name, Chakri, and his last name is Cherukuri, which is Cherukuri. Make sure to follow him there. Chakri, thank you so much for being on the show and sharing your insights, the work that you're doing around machine learning and financial data, and also just your wonderful advice on helping those who are just getting started.
Thanks a lot, Mike, for having me on this podcast.
Thanks so much.
Thank you.
Hey, everybody. Thank you so much for checking out this episode of the Data Talk podcast. My name is Mike Delgado, and we record this show every single week on Facebook Live. If you found this show helpful, please let us know by rating us on iTunes. And if you want to know about past episodes or upcoming ones, you can always go to the Experian blog. The URL is just experian.com/datatalk. Again, that's experian.com/datatalk. And that'll bring you over to the page where we have a listing of all of our show notes and past episodes. We've recorded over 100 so far. And we're also looking for your recommendations. So if you ever have suggestions around topics or guests you'd like to hear from, please let us know. You can reach out to us on Twitter. Our Twitter handle is @ExperianDataLab, or you can just reach me directly @Mike Delgado. Thanks so much for your support, and thanks so much for subscribing to our shows.